you can hear me, right? Okay, I can hear myself, so that's something. The best presentation, that is not true. All the presentations have been quite great, and I'm very sure that tomorrow there are going to be a lot of more presentations, super great, and I hope I can see you there tomorrow as well. Now, cannot deny, I feel very humbled to be in front of all these people, all these amazing people. I am also a bit full of emotions, but I don't know, they say that when you have when you have this stage fright, you should picture everyone naked. Don't worry about it, I can see only the first row. Don't worry about that too, I also don't have my glasses, so all is good. All right, so let's begin. If this works. A bit about myself. So I am Diana. I am passionate about technology and innovation, and that includes data and AI and machine learning. I pursued my passion for this area by studying a master's in machine learning in Germany. I'm currently a senior consultant at Deloitte, and I have been in consulting for around 3 years now. My job is to help clients develop innovative solutions to their challenges. So, today's topic is LLM fine-tuning. More particularly, we are going to cover first, what is an LLM? Then we're going to understand how does it work, so what is the intuition behind that. After that, we are going to talk a bit fine-tuning and what is that, and perhaps when should we use that, what are some good use cases, and finally, some challenges and opportunities. Now, let's get started. All right, this didn't work, but yeah. Good. And we're going to do that in an example-based fashion. So we invite here right on stage with us Alex. So Alex is a hypothetical character. She doesn't exist in real life. Maybe she will exist in future editions of MDC. So she's part of the Moldova Developer Conference team, and her job is to help MDC enthusiasts to stay informed, to get recommendations, and to provide feedback regarding the conference. There is, however, a second part of her job, which is to make sure that it's possible to collect metadata about user queries. So, for example, if users ask questions about speakers or about participants or whatever common asked questions, you want to catch that kind of information. You want to understand what is trending. So the first approach would be, why not set up an FAQ page? And she did that. Well, we see that is a screenshot from the website. Now, it's a good solution. It provides information, but it doesn't really help a lot with the recommendation. Maybe there is some information about how do you want to dress, because there's an after party and maybe you want to look fancy or something. But it doesn't enable you to provide any feedback, so you cannot really look at that text and say, hey, I have a feedback or something. And it also doesn't enable us to understand what kind of questions have there been or what kind of troubles do the MDC participants normally go through. So basically what we see is that this doesn't totally fulfill the requirements. Okay, approach number 2. And that approach is to set up a Google form or simply receive all the queries, all the questions per email, and then manually process that, provide all of this information, and also manually collect the metadata, so sort things out, and manually save it into some sort of file. Again, not the best solution because that, while it fulfills the requirements, it doesn't really make sense in terms of time. It's time-consuming and it's slow. And the approach number 3 would be to set up an AI-enabled assistant, and this is great. This fulfills all the requirements, and most importantly, it can also be automated. Now, let's take a look how a general solution would look like. Now, it doesn't really matter what happens in this right side of the presentation, but just to briefly mention, we have the user. It interacts with some sort of front end, whether it's like a chat app or whatever that we set up. Then we have the backend side, which does some sort of logic, stores some stuff in the database, and so on. And then we have the third part, which is the AI-enabled component. Now, this is also the part that we are going to focus on. And the question arises, what should be this AI component? what could we use? Well, I think that's yet another presentation that doesn't hesitate to use the OpenAI and GPT substring. But that's right, that's what Alex also used, the GPT API from OpenAI. Now, before we go into how would one implement that, let's briefly define our task at hand. So task number 1 is to have an assistant that is able to process natural language, to understand it, and then provide responses accordingly. Now, responses could be to information, or responses could be to feedback that needs to be collected, or responses could be to recommendations regarding whatever users fancy. And then there's a second part, which is to collect metadata information, more particularly to kind of classify what the query or the question is about, be it general, about the conference in general, or participant, speaker duration, blah, blah, blah. And then we have the intent. What is the user trying to do? Is the user trying to get some information, to provide some feedback, to get some recommendation, and so on? Particularly for the feedback part, it's also important to understand what kind of sentiment do we have that. Is that a critical feedback? Is there something that we need to pay attention to in the future? And then, of course, the language perhaps could be also interesting. And this is how it would more or less look like. We have the question that comes from the user, like what is MDC? And then we have the output. So we want to output this JSON-like object where we have the output, what the user would be able to see, and then we have the tags that are interesting for us as conference organizers. All right, so task implementation. In order to do that, she set up then an account with OpenAI. And this is some Python code that she did in order to get the results. First of all, fetching the API key from the environment or whatever configuration she chooses to have. Then we have the completion part, which, okay, there are a lot of question marks here for some reason. Then we have the completion API, which specifies a couple of things. So first, the model that we're going to use, in this case, GPT-3 Turbo, 3.5 Turbo. Then we have the messages. So first, the system configuration message. We have already seen a presentation that has shown us what would be the system configuration for. And then we have the question itself. So let's take a look at the results. We have the system that you are a chatbot that answers questions regarding MDC. And the question would be, what is MDC? MDC stands for Metropolitan Democratic Club. Well, that's a bummer. That's not what we expect. That's not even close. We maybe want something like MDC is like the coolest and largest IT conference in Moldova. Then she thought of an idea. Why not include in the prompt what MDC means? And by the way, prompt, we mean like this text that we provide to the AI component. And then to the same question, it did better. It did actually much better. We can see that now it understands what MDC is for. It even provides some blah, blah, blah text. And then it's still too long compared to what we would expect from the output to be. But at least it got the result right. Then there's another thing that she tried, which is asking how many participants attend MDC each year. And the output was that there are several hundreds. Now, we're not very happy about that because actually there are 450, and maybe we want a number in that range. A couple of hundreds could mean maybe 200s or 900s, and these are very, very different numbers. So then the next idea would be, okay, let me include this information as context in the prompt, and then let me tell it to use this context in order to answer my question. She did that. And this time it did well. This time it responded how we wanted. It's quite similar actually to the answer that we would expect, or the approximate expected answer. It does well, except these are some, so it doesn't respect the form. It just gives text. It's good, it's useful, but it doesn't fulfill totally the requirements. And then you guessed it right, probably. You need to explain what form you need your results in. And then we have this example. We tried it again, and it did quite well. It respects the form, it gives the right output, but it's not very good at tags yet, and it's not very good, for example, for the intent. It's a number of participants. Our intent is like 3 types: feedback, recommend, and inform. So it's not right. Next step, provide extra information about that, and let's see how it performed. Now it looks good. Now it's what we expect. And then we try with other examples. And it's almost good, actually. It's not perfect. It's good, but it's not perfect. Now, for example, here the question is, why should I attend MDC? And then the sentiment of that sentence was classified as positive. Now, that's not positive. That's just neutral. There's no positive sentiment in there. Or, for example, here the question was about how many speakers are there at MDC in 2023. And by the way, we are expecting the answer 21 speakers because I told it so in the context. I used the data from last year. And then it used the tags participants and speakers, and the question was not at all about participants. It was just about the speakers. So, can we make it better? Hopefully, yes. Otherwise, we would stop the presentation here and go home. There are two approaches that we can do that. The first one is to keep engineering the prompt a bit further, so refining it, giving it more context, explaining maybe how we expect the answer to be. And then there's a second approach, which is fine-tuning the large language model. And in this talk, we're going to do that. All right, so LLM, large language model fine-tuning. So let's cover first the LLM part. What is an LLM? An LLM stands for a large language model. It's a deep learning model. It has neural networks in the background. It's actually also based on the transformer architecture. And it's large because it has a lot of parameters. And we are talking about billions or even hundreds of billions of parameters. That's a lot. That's huge. The second part is it has been trained on massive amounts of data. So it downloaded a lot of the part from the internet, most of the popular known large language models. And third, it has many capabilities. So it can translate, it can summarize stuff, or it can make stuff even longer. Sometimes it's quite useful to do that. It can write poems, it can do many, many things. So it can be adapted to have many capabilities. Now, what is the intuition behind? Now, this text generation large language model intuition is basically you have a sentence, or you have some text, and then based on the text that you have, based on the words, you want to predict what is the next word. In this case, I ate bread with, and then we could think of jelly, jam, banana, whatever. More technically, this looks actually like this. So we have our sentence. Now, those are not really the words, those are the tokens. We covered that again in a previous presentation. Think of tokens just as words or sub-parts of words. Like, for example, if you have eating, maybe eat and ing could be like 2 tokens, so that you could reuse ing for other verbs like running, presenting, and so on. Now, we pass these tokens into, based on the tokens, we create vector representation of these words that we further on pass to the large language model, because the large language model understands numbers, vectors, it doesn't really understand text. And then finally, we output the vector representation of the next token. And then the way we choose that, which would be the next token, is hopefully something that makes sense, and not just a random word from our whole vocabulary, not a random token. And some words then are more likely than others. Now, let's go to the second part, which is the LLM fine-tuning. So fine-tuning is basically further training a model on a smaller, usually smaller data set, while starting from a pre-trained model. Now, what is the difference between pre-training and fine-tuning? In pre-training, you typically start from random parameters. So if you would try to use this random parameters model to generate some text, it will blurt stuff that doesn't make any sense. Just like we will do after the after party. And then we will feed it a large language model and an optimizer with its optimizer configuration to finally, after many iterations, get the pre-trained model parameters. And then the fine-tuning part, it's quite similar actually. We again have an optimizer with its information. This time we have a smaller data set, and instead of starting from a random setup, we start from the pre-trained parameters from the previous stage, and then we fine-tune the model to obtain the fine-tuned parameters, which in the end would mean that the large language model is able to perform what we need it to. Now, let's go back to Alex and her example. So she decided to fine-tune an OpenAI model. Now, to fine-tune an OpenAI model, there are 4 things that you need to do. Okay, that would be 4. First one is data set preparation. The second one is creating an OpenAI file. The third one would be to create a fine-tuning job. And the last one would be to use the fine-tune job in order to create your recommendation, your generation. All right, so part number 1 would be creating the data set. Now, the structure is something like that. You need to provide the role. Again, that's for the completions, chat completions API. The role for the system, role for the user, and then how you want your output to look like. So basically, we have many, many, many examples of how might a question look like from an MDC enthusiast, and then on the other side, the JSON-like output. And we give more examples so that the model already gets to know what it means. And then gets to behave in this way, to create these kind of predictions. Part number 2, you then take this JSON file that you just created, and with the help of the OpenAI library, you just upload that to OpenAI. And part number 3 is where you actually create the fine-tuning job. So you then provide the training file. It will have a unique ID that will look like file minus some ugly stuff. And then the model itself that you want to fine-tune. And then you go have a coffee, or more coffees, because it can take from 1 minute to a couple of hours before the fine-tuning job actually starts. So it could be that there is a high demand, I experienced that, but it could be that the job starts the fine-tuning process right away. Okay, and then finally you can use the model. So what you do is very similar to what we have seen in the beginning, except this time, instead of having the model GPT-3 0.5 Turbo, we have a fine-tuned version of it, which looks something like this pattern. And then we provide, again, the system role, and then the question from the user. Now, how did that perform? Let's see. So, again, we have the same question. What is MDC? This time, it looks a bit better. It looks like it has respected the form. We have another examples, how many participants. Again, we are not giving this information in the context. It already has learned. And we can see that it said, okay, this year, MDC expects more than 400 participants. Well, that is true. That is true. It's not exactly the number that we expected. Maybe 450 would have been like the perfect answer. It said 400. The same thing happened kind of for the speakers. So it said there are 20 plus speakers at MDC normally. And there are more examples. For example, there's a question. My friend said I should join MDC. Is it for me? The output, if your friend knows you well, then definitely ... No, I'm kidding, MDC is great. And there are more examples that this just works. It works as we expected. But again, with those numbers, maybe it didn't make so much sense. It made a bit, but we can discuss a bit about that in a couple of slides. Now, how to make my results better. And there's one way in which you can do that. First one would be you get more data. So what Alex has also tried is to take kind of the same question and ask it differently and reformulate also a bit the answer and then reproduce it a couple of times. And this has improved the performance. The second part was, if you're going the prompt engineering approach, to write better prompts, to try to really see what are some trending ways to do that. Every now and then we see a new kind of prompt engineering technique that really helps. And sometimes combining the two can also be useful. Now, this is my favorite question of tonight. And from now on, we are going to discuss a couple of more such questions in order to understand, is this something we want to do? Is this useful for me and my company or not? So let's check it out. Do I really need fine-tuning? And the answer is probably not. You probably do not need fine-tuning. But in order to understand why do you maybe not need fine-tuning, you have to understand when to use fine-tuning. And perhaps this is the most important part of the presentation. Generally, fine-tuning is for form and not facts. It can help your model adjust its behave in a way that you want it to, but if you want it to be like super accurate, give you super great factual information, there are better approaches to do that. Now, examples in which you could use fine-tuning, as mentioned, is when you want the model to behave a certain way, and it's a bit difficult to explain. Like, for example, this use case here, we have some natural language that sounds like, how many heads of departments are older than 56? And then you have an equivalent SQL query that is select count star from head where age greater than 56. Now this is an excellent example when fine-tuning would be a very, very good fit, because it would be difficult to explain to the model how to translate this natural language into SQL. Another great example would be then data to natural language text. So if you have some sort of data source, it has some sort of information, and you want to translate this information into something that is useful, something that for a human person would mean something. Like in this case, we have some sort of video game situation, and then they have the release year and then specifier terrible, and then this has been translated into were there even any terrible games in 2014. So this is something that is a good example of fine-tuning. Now, I will not spend too much time on this slide because we already have an amazing presentation earlier. You should check it out. So the online people, I think you have seen that, but if you didn't, I guess we will all have the recordings and we can check it out as well. It's an overly simplified slide. Of course, we have seen that it's much more complicated than that. But basically what would be our use case, we have information about participants, speakers, venue, parking, blah, blah, blah. And then we have the question, how many participants are going to be there in 2023? Then you will probably take the chunk of information that is related to the speakers or participants. I don't remember even what I asked. So probably you will just fetch the information that is relevant to the question. Yeah, let's address the big elephant in the room. How much does it cost? Now, for this particular example, and remember, we have like a baby toy example, something very, very small. Let's take a look. So first of all, what are the prices? So the OpenAI stated these prices on their website. We have different sorts of model. We particularly use the GPT 3.5 Turbo with the context length of 4K. And the input usage, so the price for our prompt is $0.0015 for 1,000 tokens of the input itself, and then for the output, it's $0.02 the cost. Now, let's take a look at the prices for fine-tuning. Again, we fine-tune GPT 3.5 Turbo. It's a bit different, the table, because there's also the associated cost for training. Okay, in this case, training, but the term is actually for fine-tuning. So for 1,000 tokens, it costs 0.008. Now, something interesting happens in the columns for input and then for output usage. This time, the input usage is more expensive. So we went from 0.0015 to 0.012. Now, that's almost an order of magnitude. That's not nice. That's not good. And then the output part, so how much we will be charged for creating this JSON-like shape would be 0.016, which again, it's more expensive. So it used to be 0.02. So for our use case at hand, what does that mean? Let's write it down. What are our assumptions? So assumption number one would be that we have around 400 participants, and each participant has a budget of about 10 questions, not 450, hopefully. Then we have the length of the long context prompt, so the one that we explain what is like MDC and what are data about the MDC participants, speakers, blah, 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 together with the pattern explanation and so on. That would have around 700 tokens. Then for the short context input prompt would be basically the length of the question that we address, and the generated output, so this JSON-like thing would have around 50 tokens. Now, these are the costs. So on this side, we have the cost for the pre-train. Now, again, with the assumptions that we have, the estimation for the input part, where we give the prompt and the context and so on, would be around $4.72, which again is just a price that probably NDC could afford. It's not a big price, but it could get tricky in case we have a conference that is a bit bigger, maybe something like Website Summit, where we have 100,000 participants each year. So yeah, this is the price for the pre-trained input. It's cheaper for the pre-trained output because the resulting string is shorter than what we provide as the input query. Then the right side would be then the prices for the fine-tuned input. We can see that, as we expect actually for the fine-tuned input, the prices are smaller because now we just have to ask our question, no longer to have to provide extra information about the pattern and so on. But something happened to the fine-tuned output. We went from 0.45 to 3.6. Now that's a lot. That's a lot of money. That's a lot of, I don't know, team buildings or something. I mean, for this data set, not, but if we are talking about a use case that you might have in your company that could technically matter. And then we have a total of 5.22 for the pre-train, a total of 4.41 for the fine-tune. Now, that's not totally true. There's also the associated cost for the training itself. So the data set that I have used is estimated to be around 11,000, and then we have an updated cost for that. I will go back if this will work. Now, in this case, it did make sense to fine-tune. Still, it's not a huge difference, but it's still something. And it will make sense in cases in which your output is short. If your output is larger, maybe RAG would be something that you should consider. All right, so the last two things that I will cover for today will be, what if you have privacy concern? I still have 3 minutes, don't look at me like that. I don't know,
No, I'm not judging people, I was looking at the numbers.
Okay, all right, so let's imagine another use case. We have a technology firm that uses an internal programming language. Now, this is like the most amazing language in the world. It's like top secret, it's super great. And the engineers want to use a code completion tool, so some sort of like GitHub Copilot, but something internal. And they don't want this data set to, the training, the code, to be leaked somewhere in the wide internet, meaning that they don't want to send their data to OpenAI. And this is something that a lot of firms care about. A lot of firms don't want to send their data to a service that doesn't maybe even allow them to delete it. Like, for example, the files that have been uploaded with the MDC, unfortunately, that has happened. Sorry for that. But yeah, we have this use case. Now, there are open source models, and you can fine-tune your own open source models. There are many of them, including Llama, Llama 2, Bloom, and so on, Falcon. You can check this out. Probably in a month, this will be outdated because things change so much. Now, this is tough. This is difficult because of a couple of reasons. The number one reason being you need technical expertise and knowledge. You need to understand what is happening behind. You typically also need GPUs, and they tend to be quite expensive. And one thing that one doesn't really think about is that you would need more VRAM than you think, much more VRAM than you think. And let me explain why. So typically, this is how a training loop looks like. Well, except the first part that you do only once. You load the data and the model parameters. You then make the predictions. You calculate the error, how far you were from the predictions. You calculate the gradients, and then you update the model in order for it to have better parameters and produce better predictions. And then you repeat steps 2 to 4 a couple of times. Okay, so on the other side, let's imagine that we are poor. No, we are poor. We don't need to imagine that. Yeah, let's imagine that we need to use a development environment that is very, very simple, something like Google Colab, which would give you a GPU typically, and that would be a T4 by default if you don't have any fancy subscription. And then for the purpose of visualization, imagine that each of these square is 1 gigabyte, so this GPU would give you around 16 gigabytes. Now, okay, let's proceed to step number 1. Let's load the model parameters. Uh-oh, we need a bit more memory than this GPU would give us just to load the parameters. So one parameter would be stored in 32-bit, which would be 4 bytes. Then 1 billion parameters would mean 4 gigabytes, and then 7 billion parameters, which is something that Llama 2 7 billion has, would need 28 gigabytes. Now that's for loading the model. That would be if you need to also fine-tune, which is something that we're doing here, which would amount to 28 gigabytes itself. Then there's the optimizer state. So if you want to fine-tune, and that could be even 56 gigabytes if you have something like Atom. And finally, this is how much you have. This is how much you need. You have 16 gigabytes, you need 112. And just briefly to mention, one possible solution for that is PEFT, parameter-efficient fine-tuning. So for example, with quantized low-rank adaptation, you could go from 112 to 13.5, which already fits into the GPU, and then you can play around with it, and it works good. And the last thought is, how much data do I need? Data is good. More data is better. High-quality data is best. Don't feed the model garbage. You'll only get garbage. All right, so key takeaways from today. Fine-tuning is great to teach your model form, not facts. Prompt engineer before you fine-tune. It could be that you can already do the stuff that you want to do with prompt engineering, but also take a look at the costs. Sometimes it can get more expensive than fine-tuning. Just do your calculation, do your math. As well as open source models, you can use them in order to fine-tune on your own data set. Typically, it's more hard, but it's definitely worth it. And then the more data you have is better, but the quality is also something that matters. Thanks a lot for your attention. We ran out of time. I don't know if we have time for questions.
Well, yeah, as promised, one question we can have. Yeah, so please.
It's not really working, but okay, you can say the question.
I do have one question, but first, thank you for your presentation. It was great. I loved the examples that you provided. And you mentioned about the open source large language models that you can use. And I know that they are typically worse performing than OpenAI models, such as GPT-4, but GPT-4 is also more expensive. We all know that. And can fine-tuning help you in using an open source model and make it better?
That's a very good question. Thank you very much for that. Yes, definitely fine-tuning can help you with that. Well, the software did not agree with me, obviously.
Sorry for that.
It can help you with that, and I have even seen resources of like people trying to fine-tune not only the open source models, but also the other kind of models, and they end up performing better. Now, I have seen a comparison of fine-tuned models that are open source with GPT-4, and I don't think they had the chance to fine-tune also GPT-4 on the data set that they were testing, but they have shown that after fine-tuning on some data sets, some of these models actually did outperform GPT-4, which is a very good result. Thank you.
Yeah, thank you. Thank you, Diana, for your presentation.